Here's a question for you. Are we just a cosmic accident, or was something like us, an intelligent tool-using species, pretty much bound to happen? This isn't just late-night philosophy, folks. This is one of the biggest, most fascinating debates in all of science.
And it all boils down to this one thought experiment. Imagine you could rewind the tape of life, all 4 billion years of it, and hit play again. Would the story unfold the same way? Would anything remotely like us ever show up? How you answer that question puts you on one side of a huge scientific fault line.
And this debate really boils down to two big ideas. On one side, you have contingency. That's the view that life is basically just one random accident after another. But on the other side, you've got convergence, the belief that evolution is actually pretty predictable, and it's forced to find the same answers to life's problems over and over again.
Now, these aren't just some abstract theories. They were championed by two of the most brilliant paleontologists of our time. You had Stephen Jay Gould, who was the master of contingency, arguing for the beautiful randomness of it all. And in the other corner, Simon Conway Morris, who saw these incredible, predictable patterns written right into the fabric of biology. Okay, so let's start with Gould's side of the story. This is the case for contingency, where random chance and historical accidents are everything. So what does contingency actually mean? Well, it means evolution is what we call path-dependent. A tiny little chance event that happened millions of years ago could have set life down a completely different track. If that happened, today the planet might be dominated by, I don't know, intelligent insects or something. Every single outcome is incredibly fragile. Gould himself put it perfectly. He argued that evolution isn't some grand march of progress, of life constantly getting better and better. No, he said it's a story of brutal, random extinctions where just a few lucky survivors get to write the next chapter. It's not about being the best. It's about being the luckiest. And if you want the ultimate proof of how a single accident can change literally everything, we just have to look back to one catastrophic day in Earth's deep past. That's right, a rock 6 miles wide came screaming out of space and slammed into the planet. It wiped out the dinosaurs, who had been the undisputed kings for over 150 million years. Without that one totally random event, our tiny little mammalian ancestors, they probably would have just stayed scurrying in the shadows. No asteroid, no us. That right there is the power of contingency. But of course, that's only half the story. So now, let's flip the coin and explore the other side of this debate, the compelling case for inevitable, repeating patterns in evolution. This is the idea of convergence. The theory here is that the laws of physics and the rules of chemistry create a kind of limited toolkit for life. There are only so many good solutions to life's challenges. So evolution, no matter where or when it's happening, will eventually stumble upon these same amazing solutions again and again. And the evidence for this is just stunning. I mean, take the eye. It's an incredibly complex organ, right? But get this, it has evolved from scratch, completely independently, more than 40 times in totally different species, from insects to octopuses to us. It's like, if you need to see, evolution has a go-to blueprint it just keeps using. Or just look at this, it's a perfect example. On the left, you've got an ichthyosaur, that's an ancient reptile. On the right, a dolphin, a mammal. They are separated by millions of years on totally different branches of the tree of life. And yet, to solve the problem of how to move fast through water, evolution gave them both the exact same design: a streamlined body, fins, and flippers. That is convergence in action. It's incredible. So, we've got these random accidents on one side and these inevitable patterns on the other. But this brings us to the biggest, trickiest puzzle of them all: us. Where does our kind of intelligence fit into this picture? Think about it. After 4 billion years of life on this planet, with countless trillions of organisms living and dying, how many species have developed the ability to build telescopes in spaceships? Just one: us. This single, stark number is the biggest challenge there is for the idea of convergence. So what gives? If having a big brain and using technology is such a great evolutionary solution, why hasn't it happened over and over again, like the eye or the flipper? Is our kind of intelligence just a complete fluke, a 1 in a trillion contingent accident? Or is it just an incredibly rare and difficult solution for evolution to find? This is where things get really interesting, because we now have modern experiments with digital life.
In these computer simulations, like one called Avita, scientists create little computer programs that evolve inside a machine. And what they find is fascinating. The digital life forms often take completely unique, random, contingent paths. But when they face a really complex problem, they often converge on the exact same elegant solution. It seems like both forces, randomness and predictability, are constantly at work, side by side.
Now, this entire debate isn't just some academic exercise about Earth's past. It scales up, way up, to one of the biggest questions we can possibly ask about our place in the cosmos.
Yeah, it connects directly to the Fermi paradox. You've probably heard of it. The physicist Enrico Fermi famously asked, if the universe is so vast and so old and life is probably common, then where is everybody? Why the deep cosmic silence? Well, the answer might actually lie in which one of these two evolutionary forces is stronger.
The implications here are just profound. I mean, think about it. If contingency is the rule, then a species like us is a staggering statistical improbability. We are a cosmic lottery winner. And that great silence out there is exactly what we should expect, because we're likely all alone. But if convergence is the dominant force, then the universe could be absolutely filled with intelligence, because evolution, given enough time, will find that solution again and again.
And that brings us right back to where we started. So what are we? The result of a long, improbable chain of cosmic accidents? Or is our very existence proof of the predictable, creative power of evolution? The answer doesn't just determine how we see our past. It determines whether we should ever expect to find neighbors out there among the stars.